I think that's still a little too.
Okay, so what we're going to do here is, hold on one sec. I'm going to, is this it? No. Is this it? Yeah, here it is. Okay. We spent all this time on meditation, on Radically Happy. And this YouTube here, these are the two authors of the book. So I thought I would just play this just as a little summary, as a plug for why you should meditate. So here we go.
Good evening. My name is Julie Gillette, and I'd like to welcome you on behalf of the Buddhist Ministry Initiative at Harvard Divinity School. Tonight we have the pleasure of welcoming Pakchok Rinpoche and Eric Solomon to speak about their new book, Radically Happy, A User's Guide to the Mind. Pakchok Rinpoche is part of a new generation of Tibetan Buddhist teachers who seek to combine traditional wisdom teachings with participation in modern life. He was born in 1981 to a family known for their spiritual accomplishment and recognized as the seventh Pakchok Rinpoche, an incarnation of a great teacher and meditation master. He received ordination from His Holiness the Dalai Lama and completed traditional training in Buddhist philosophy and meditation, studying with some of the most accomplished masters of modern times. His main teachers being his grandfather, Kyabje Tulku Urgyen Rinpoche, and Yoshoken Rinpoche. Rinpoche completed his education at Dzongsar Institute of Advanced Buddhist Studies, where he received the Kempo title. He seeks to combine the scholarly tradition of his studies with the experiential tradition of his main teachers. Eric Solomon has a career as a Silicon Valley technology entrepreneur and now as an author and innovative meditation teacher. He's been interested in understanding the mind and how it functions, both as a user experience designer and as a mind hacker. Eric's interest in human-computer interaction took shape when, as a teenager, he taught programming to children and school teachers. As a participant in the LOGO group at MIT's Artificial Intelligence Laboratory, he interacted with some of the world's deepest thinkers on how to make intelligent machines. This experience inspired a passion to understand the mind and how it functions, and led him to the study of Buddhist theories of the mind. Eric has studied and practiced Buddhism for more than 2 decades and completed a traditional Tibetan Buddhist 3-year retreat. He's been invited to speak and lead seminars and retreats in corporate settings such as the World Bank and Silicon Valley tech firms, as well as in prisons, temples, and Buddhist centers across the US and Europe. This evening, they'll join in a conversation around the recently released book, Radically Happy, which is an effort to make meditation, mindfulness, and Buddhist thought accessible to a modern secular audience. Please join me in welcoming Pakchok Rinpoche and Eric Solomon.
Thank you very much, and very happy to be back again. First, I want to say that why we make together, and our connection actually is first is friendship over 20 years, and the second is my meditation teacher. Actually, is the first one is my grandfather, so his meditation teacher was my grandfather too. So because of that, it have some kind of connection. And so that is number one. Number two, I'm actually giving teachings going to variety of countries and world and meeting different people. So one thing that I keep coming up is the way to approach is not actually effective enough. I know that people like to hear it, what I wanted to say, but the way how I do it is not actually going through the message. Then I met again 5 years ago after he came from the practice, and we met up. Then he's have a lot of experiences through doing all the programmings and all that, and he has a similar idea. I have a similar idea, and we say, okay, why we don't do something? Then slowly we came up, and we came up with this book. Now the book is really funny because the first is radically and the second is happiness. So a lot of practitioners, all practitioners, meditation practitioners or whatever practitioners, when they hear of word of happiness, it's not so appealing. They feel like it's, oh yeah, again it's a cheap stuff, or dealing with your own thing, or some kind of self-help book type of the word. That's why we put radically, because my friend Eric said the radically Latin actually means root. So root of happiness, or radical actually means doing a little bit different way. So that is the reason behind we put radically. And some of the friends that I met, they're always saying that to me that, oh, it's very difficult to be happy. And so I say, okay, this kind of person, then that's why we put happiness for you to understand. We don't want to say freedom. We don't want to say big words to explain. Why we chose actually happiness word, the word of happiness, because everybody actually understand kind of. Of course, they understand differently, but everybody wants that happiness. And some of my colleagues, of course, I thought about it. I'm a quite traditional person as a meditation devotee under my meditation guidance masters. So that it's okay to use happiness word. And actually, in my understanding, you can, because in the meditation devotees, they always say short-term results or short-term happiness and long-term bliss or long-term freedom. And because of the reason, when you don't see any benefits right now, and people are not going to be appealed towards the practice to gain some freedom from in the future. So you don't see the result now, you know that you're not going to put effort to have result in the future. The whole idea is you need to get some result right now. So that is the whole reason behind that it came up. And so in this idea in the book, we have created three perspective of idea of happiness. The first actually called a basic happiness. Is kind of developing steadiness within yourself, and they have three steps in there. And the second one is called interconnected happiness, is actually developing warm-hearted. This is what Eric likes to say, and I like to say the word is called kind, not be kind or not kindness, just the word of kind. To feel kind, not to yourself, not to others, just to feel the kind is very, very important. So cultivating compassion, cultivating warm-hearted kind is the second interconnected happiness. That they have three steps again. And the third one called radical happiness, they have three steps. So the idea of the radical happiness, the first step is actually called cultivating the dignity. And it's a very important that in life, that when you know exactly what you want to become, or you know exactly who you are, or you are okay with yourself, or situations, or meditations, or whatever, you can actually achieve. It's achievable. When you're confused, you have doubt, and you cannot achieve, and you have a lot of difficulties. So cultivating dignity is very important. And that's why the first in radical happiness actually called cultivating dignity is the first step. And the whole idea that Eric and me, we came out with the book is, don't give too many talks. Give them what to do. Because I go to secular section or religious section or philosophical section or meditation section. Whatever section I go, everybody says the same thing. The love is important, kindness is important, compassion is important, happiness is important. Everybody says that. Secular way or a religious way or a meditation way or philosophical way. Everybody talk about that. But the point is that we all talk about it. But my question is how to get it. What is the step by step? Tell me how to do it. Telling I need to have that. Of course, I know that. without you telling me. I know that I'm seeking for happiness. I don't want to seek for suffering. Of course, that is something everybody is like that. But then the point is how to get it. So that's why in that book, we actually put together 28 exercises. And we don't want to use too much of the word of meditation because now there's so much use the meditation, the word. I feel actually heavy when you hear, when I come to America, US, and when I hear the meditation, I feel heavy. I don't know why. When I go back to Asia, I hear meditation, I don't feel heavy. I feel as, yeah, it's a kind of thing, right? But when I come to America in US, and I say meditation, I feel like that. So because of that reason, we use the word called exercise, and actually it's true. It's a mental exercise. So that is the idea that I want to begin with. And before I'm going to give to Eric, I want to say that when I went to see my meditation teacher, and I was 18 years old, I think that is one of the biggest kind of how you say the biggest move in my life. And actually, I studied in like this, Harvard Divinity Religious School. Like that, I actually went to Buddhist, really Buddhist college. They only talk about Buddhism, and of course they talk about Hinduism and all other religions, of course. But I am atheist. I believe in atheists in the religion, into my scholar when I study. I actually don't like to be in Buddhist. So whole school I have 30 students, and I am the only atheist, Buddhist atheist. So I'm a very short temper. I'm very angry. I'm pissed off with life, and I punch the walls. I don't punch people because I'm a Buddhist. Kind of Buddhist ethic, not the Buddhist beliefs, but Buddhist ethic kind of. So because of this whole reason, I don't want to punch a person, but I want to punch the wall, and it's true. So I went back to my holiday. I went to see my father. Then I told him, I said, something is wrong with me. And my meditation teacher says, come right now. So I went to see my teacher, and he's a really lovely person. He really take care of me, and he's very kind. And I went up there and I said, please teach me meditation. And he just goes there. He didn't teach meditation. He said, okay. Don't be like dog. Be like lion. And I love dogs. I don't know why he's saying that. He said that you reflect yourself. When you want to be angry, you chase after the anger and you become the anger. You actually throw a stone at a dog. Dog chase the stone. That means you actually chasing the feeling or thought arising in your mind. Then you become that, like a dog. But when you throw the stone at a lion not going to chase after the stone. Lion going to jump on the person who's throwing the stone. Like that, when you have a feeling to be angry because of habit, you have a thought, you have many small thoughts, short thoughts to be angry, or you have some condition that makes you angry. Moment that, he said, don't go after that. Look in towards who actually seeing that, who is actually becoming that. Look inwardly towards who sees. Then you become the lion. Then he said to me, you just go back and reflect me. Next day I come back. Third day I come back. After a week later I come back. And he said, whether you believe or whether you don't believe, doesn't matter to your anger. Isn't it? He said, yes, meditation master. Now you want to meditate? Yes, I like to meditate. Then he begins the meditation. So that is the thing that I am really interested in the meditation because of this example. So the point is, don't be like dog. Be like lion. Don't be like dog. Be like a lion. And I'm going to give to friend Eric.
We have a real challenge in this life right now because technology is amazing. There's so many benefits. I remember actually there's a few people in the room tonight who had just an enormous, profound effect. One is my aunt, C.P. Solomon, who was working in the 60s and 70s with some of the most brilliant people I've met. She was equal, by the way. Marvin Minsky and Seymour Papert, looking at how people think, how children think, how you can make computationally rich environments so kids can learn mathematics through culture rather than simply through learning by rote a bunch of equations. And Marvin's daughter, Margaret, is sitting here. We grew up together. And Marvin, I think, said to me when I was 10 years old, you know, self doesn't really exist. Cynthia, Marvin, and Seymour, they never condescended to children. They always talked to us like adults. And he said, you know, it's just, the mind is just a bunch of things that come together, algorithms, that their interdependence creates this illusion of self. And then my friend Gary Drescher is sitting back there, who was very inspired by a lot of this and actually for many years theorized how you can actually make intelligence in machines. And he and I used to argue until late in the night. I think that I affected his book a little bit, and he affected mine a little bit. And it's a rich ongoing dialogue we've had to this day. And so this is some of the wonderful parts of technology, is it gets us to think and to create and find new ways to communicate and possibly even create learning environments that we never dreamed possible. The other side of it is, of course, the constant, unrelenting interruption. We all have this thing in our pocket called a smartphone, and it's I mean, just on this book tour, I get WeChats, WhatsApps, emails, SMSs, you know, phone calls, whatever they are, and et cetera. And, you know, it's wonderful. Everybody's trying to be supportive or trying. I've had people I haven't seen for decades show up at some of our talks. And I could be doing something every moment of the day, even while I'm sleeping. We're all trying to cope with this, everybody. Last night, I was talking to some teenagers about how they're coping with it, and the fact that one of them just had a false alarm at their school, where they thought there was a shooter, and she said, you know, we see it all day long on our telephones, how our parents aren't protecting us, and you know. In the old days, I remember hiding under my desk. We were being trained, you know, in case there was nuclear attack, as if hiding under our desk would do anything. And, you know, okay, that was frightening. But imagine, I mean, today it's all there. It's all so visceral. And all of us are trying to find a way to cope. All of us together. And a little bit what Rinpoche and I each in different ways began to notice. I was working on leading development of a meditation program, both online and offline, in the early part of the 2010s. Rinpoche's been traveling. I've known him since he was that bratty teenager that we're talking about, by the way. And he's just blossomed into this amazing teacher. But while he's been on his, you know, teaching tours, he started to notice something very similar, that where we traditionally start in teaching about the mind and meditation and compassion, it's not always meeting people where they are in today's always on, completely wired world. So we started thinking, well, what could we give ourselves? What could we give our friends? What could we give our family, our students, that would meet them where they are? That after just even reading, actually it didn't start out as a book, it actually started as a program, and then we realized no one knows us, so we've got to write a book. But what could we give them that in this book, that after just a few pages, they could taste something meaningful that could affect their lives almost immediately. So we built this book around this ancient example, this don't be like a dog, be like a lion. We're always chasing our thoughts and emotions like a dog chasing stones. Instead of turning to look at where those thoughts and emotions come from? Who? The who. Instead of always going this way, turning to look. You know, everyone knows we can't find happiness in circumstances. And yet, in the midst of a perfect day, you've all done it, I do it, lean back and say with a sigh, oh, too bad every day can't be like this. In the middle of this great moment, we're already a little bit thinking too bad. Is there anyone who's never said this? Too bad every day can't be like this? Yeah. I don't believe. I've been asking this the entire tour. Here's the one. Tonight I found out. Thank you. So we have to put our attention sometimes in a different place.
Okay, so I'm just trying to give you a taste. This video goes for over an hour, but these are, again, the authors of the book Radically Happy, and it's on the website. It's on the religion tab. You just scroll down and you'll see it there. So that's, you can see they're stressing, the whole point in the book was to give you something to act on so that you could actually get somewhere and not just philosophize over what's going on. Let's see, we picked up Barbara and we picked up Stephen. So just again, what we just did was we're trying to spend a little bit of time on meditation, and that was, we went through this book, Radically Happy, and those were the authors of the book. They did a talk at, which is on YouTube, and you can look at it. Okay, so next thing we're going to do is try and go back and address, Stephen's issues. And what we have here, I'm going to go to, first of all, to share screen here. Okay. And so what we've been talking about is what Ron Cowan observed. We have this picture here of a 26 real dimensional universe, the world around us. And it has 10 dimensions for matter, 10 dimensions for dark matter, and then another 6 dimensions that synchronize everything between these, what's going on here. Now, the thing that comes up again and again is that we have 18 of these dimensions are what are called compactified dimensions. And so Stephen has been pushing to try and dig into what does it mean to be compactified or rolled up, or a very, very small dimension. So I'm going to try and address that tonight. We'll see if I succeed. So what I'm going to do is I'm going to go back to, hold on one sec. Yeah, okay, hold on. We're going to go back to, we've been talking about what we said were imaginary numbers, or dealing with the square root of -1. So we have a picture here, and it shows, here's an imaginary number, 3 plus 5 times the square root of -1. So it's depicted here as the 3, actually there's a plane here for this. So the plane has a real axis and an imaginary axis. And on the real axis, we would plot the number 3. So we go out here 3 units. And then on this imaginary axis, we'd go up 5 units here. And that would give us some point out here. Now, this point, it has a real part, it has an imaginary part. Imaginary part is this 5 multiplied to the square root of -1. This is actually a single complex number. So in that sense, if you believe that complex numbers are just you know, a different type of number, then it's really only one dimension, even though the picture we have here is of 2 dimensions. It's a plane, okay? And over here, I put up, just to give you some idea of what in the world's going on here, we have this stuff called the integers here. So that's 1, 2, 3, 4, etc. And we go to the natural numbers here. So the natural numbers include the number 0. 0 is not included in the integers. And we can also include negative integers. So we can go -1, -2, -3. So that's what we've got here. Then this picture shows rational numbers that include these. The rational numbers are simply ratios of integers. Ratios of integers. So that subsumes all of this. Then we have the real numbers, which subsumes the rationals, the integers, and the naturals. The real numbers that encompass all of the things you could put on the other side of a decimal point. We have the irrational numbers that themselves have no way to be expressed as rational. There's no way I can find ratios of integers that will give me an irrational. So an example of an irrational number is pi. Pi is irrational. There's no way to come up with some integers that when I plug them in, I get pi exactly. And then way over here, I have imaginary numbers. That's things that are purely going purely up this axis here. And then finally, I have complex numbers. So the complex are, this can be real. The real part can be real. And the imaginary part here can also be a real number. And that subsumes everything, okay, that's going on here. So that's what we're talking about, just to set the stage. Now,
Any questions?
this is the German mathematician Kronecker said that God made the integers and man made everything else. So you can take that with a grain of salt. But
How many?
the integers are critical to everything, as you can see, looking at this picture. So now let's go back to this little. Let's see. Wait, no, there's one more thing I wanted to do down here. Hold on. No, that's okay. So now, suppose that instead of going out here some arbitrary point, I just went out here 1 unit, 1 here, okay? And I just decided to have, instead of something funny like this, I just ran around a circle. Just ran around a circle here, okay? So when I'm out here, I could think of this as being at 0 degrees. I'm right on this real line here. When I'm at 0 degrees, I'm at 1. Now, since it's a circle, let me climb around the circle. And I go all the way up here. So I'm at 1 up here, but this is the imaginary axis. So I'm up here at square root of -1. Square root of -1 is up here. Well, if I look at this, that's perpendicular to what's down here. So if I had an axis down here to get a coordinate that was perpendicular to it, this is why you heard me say you just multiply it by the square root of -1. I'm just rotating it, going over here to 1 unit up, and I'm up here at the point 1 on the imaginary axis. I can continue this just for sake of completeness. I rotate some more. Oops, hold on. I didn't want to do that. Let me get out of this. Oops, where did it go? It doesn't like me. Well, that's all I wanted to say about that. That's what I'm trying to set the stage for here. Now, let me get out of this, and I'm going to go do one other thing here, which I think is here. Okay. Now, remember we were talking about complex numbers and we had them displayed in a plane, in a two-dimensional plane here. So suppose I took this two-dimensional plane, two real dimensions, but it's really only one complex dimension, okay? And I simply chose to roll it up. So this whole plane gets rolled up here. Well, consider rolling this thing up around, say, an axis that I had as I'm looking at the world around me. So if I took my hand, here's my hand here, I'm going to say this is the x-axis, and I'm now going to wrap this thing around it. So it's wrapped around this axis, but very, very tightly. In fact, it's so tight that I can't possibly see it. That is what is meant to be a compactified dimension, a dimension that's rolled up around the axis that we see with us. So now let me just go back to what Ron did. Hold on a second. So what we have here is we have three real dimensions and then one for time. But I pointed out to you that time seems to be multiplied by I. So I is in that sense perpendicular to the three real dimensions. Oops, we lost Stephen. It's back. Okay, so time is the one that's perpendicular to the three spatial dimensions. And similarly, over here for the dark matter, we had three spatial dimensions, and the dimension for time was multiplied by square root of -1. So it's perpendicular to those three dimensions here. So time is special. But down here we have these 6 spatial dimensions. So if we took 3 of them being X, Y, and Z, but they're compactified, so they're actually right next to the 3 spatial dimensions that we have around us, but they're compactified. And then we have 3 more here that are all multiplied by the square root of -1. So they're all rotated or perpendicular to the 3 compactified dimensions here. We have 6 compactified dimensions, 3 that are real and 3 that are multiplied by the square root of -1. And that gives us a 10-dimensional space here for what is matter. And similarly for dark matter, the same exercise. And finally down here, we have these 6 dimensions, again, 3 that are real and 3 that are rotated by 90 degrees that are all multiplied by the square root of -1. And all of these are compactified around the dimensions that we see around us, X, Y, and Z, width, length, and breadth, gives us what's going on here in this picture. So it's right under our nose, but we can't see it. We don't have any instrumentation. And the one thing that Ron observed is in these compactified dimensions, there's a possibility there for you to actually control the forces and fields that are in the 3 spatial dimensions that we live in. And that was a key thing that was not obvious. And the information flow that is constantly going on throughout these compactified dimensions, throughout the compartments of space that's out there, makes everything sync up so that there's nothing that's out of sync, and so forth. So the thing that I left out, I'm going to go back to this now, is here's what we had way back when for Ron. And if I go clear down here to the end, let's see. Yeah, this is what I wanted to do. These are in book 3 of the Yoga Sutras of Patanjali, he describes what he calls mystic powers. So these are powers that could be attained if you practiced intense meditation, and in having worked at it, then along the way, you could come across the capability to do these other powers. So the powers we're talking about here are having you link into these compactified dimensions so that you can manipulate the forces and fields that you have around us. So here it is out of the actual Yoga Sutras, that in the 16th sutra in book 3, you end up with knowledge of the past and the future. You can see what happened in the past, and Ron went all the way back to where the big bounce occurred for the start of the universe, and he went way forward in time as well. In Sutra 17, you had knowledge of the speech of all creatures, so you could actually talk to, like in Harry Potter, where he talked to snakes. That's something you had. In Sutra 18, you had knowledge of your previous births there. In Sutra 19, you were actually linked, or you had knowledge of the minds of other people around you, and so forth. If I could just skip ahead here, you can see the powers of friendliness, have the strength of an elephant, to have knowledge of subtle, hidden, and remote things. So this is where Ron ended up looking deep down into the bowels of the microcosm, and he drew on this to see what is down there in the atomic and subatomic, and then clear down to the quantization of space, where space itself forms compartments, and the compartments form a foam that is what all the particles hop around in, which is what we call motion, and so forth. Then Ron actually did a lot of things where he went out and looked at the planets and the stars. We just haven't talked about it that much. You have the other capability. You don't need to eat, and you don't need to drink anything. And there are examples that people have come across of yogis that haven't eaten anything for years, and haven't drank anything. You end up evolving into a higher level. And so the knowledge of the mind and the distinction between self-intelligence and pure intelligence is an example of a subtlety, of a higher level of knowledge that you came up with. And it goes on and on. There's typically, I think, 50 of these. You can travel through the sky. For example, you can levitate. You can walk through objects, even stone. Apparently your molecules just slide in between the existing molecules of the stone. You don't get burned by fire or wet by water, or if there's a hurricane, you don't even budge, and so forth. So these are all things, these are examples of things that could be attained here. Now, I'm just going back to what Ron observed here. Yeah, that's it. Okay. So now there actually is just a couple of nice videos that I want to try and pull up on these extra dimensions, just to drive. This is someone else talking about this. So let me just try and get this. Hold on. Just a sec.
Sure. 3. Why not 7? Or
Okay, so here we go. These are a couple of short videos on about these extra dimensions. What in the world is going on here? So let's give this a shot.
This video was sponsored by the Great Courses Plus. Space, the way we experience it, has 3 dimensions: left, right, forward, backward, and up, down. But why 3? Why not 7 or 26? The answer is no one knows. But if no one knows why space has 3 dimensions, could it be that it actually has more, just that we haven't noticed for some reason? That's what we'll talk about today. The idea that space has more than 3 dimensions may sound entirely nuts, but it's a question that physicists have seriously studied for more than a century. And since there's quite a bit to say about it, this video will have 2 parts. In this part, we will talk about the origins of the idea of extra dimensions, Kaluza theory and all that. And in the next part, we will talk about more recent work on it, string theory and black holes at the Large Hadron Collider, and so on. Let us start with recalling how we describe space and objects in it. In 2 dimensions, we can put a grid on a plane, and then each point is a pair of numbers that says how far away from 0 you have to go in the horizontal and vertical direction to reach that point. The arrow pointing to that point is called a vector. This construction is not specific to 2 dimensions. You can add a 3rd direction and do exactly the same thing. And why stop there? You can no longer draw a grid for 4 dimensions of space, but you can certainly write down the vectors. They're just a row of 4 numbers. Indeed, you can construct vector spaces in any number of dimensions, even in infinitely many dimensions. And once you have vectors in these higher dimensions, you can do geometry with them, like constructing higher dimensional planes or cubes and calculating volumes or the shapes of curves and so on. And while we cannot directly draw these higher dimensional objects, we can draw their projections into lower dimensions. This, for example, is the projection of a 4-dimensional cube into 2 dimensions. Now, it might seem entirely obvious today that you can do geometry in any number of dimensions, but it's actually a fairly recent development. It wasn't until 1843 that the British mathematician Arthur Cayley wrote about the analytical geometry of n dimensions, where n could be any positive integer. Higher dimensional geometry sounds innocent, but it was a big step towards abstract mathematical thinking. It marked the beginning of what is now called pure mathematics, that is, mathematics pursued for its own sake, and not necessarily because it has an application. However, abstract mathematical concepts often turn out to be useful for physics. And these higher dimensional geometries came in really handy for physicists, because in physics, we usually do not only deal with things that sit in particular places, but with things that also move in particular directions. If you have a particle, for example, then to describe what it does, you need both a position and a momentum, where the momentum tells you the direction into which the particle moves. So actually each particle is described by a vector in a 6-dimensional space, with 3 entries for the position and 3 entries for the momentum. This 6-dimensional space is called phase space. By dealing with phase spaces, physicists became quite used to dealing with higher dimensional geometries. And naturally, they began to wonder if not the actual space that we live in could have more dimensions. This idea was first pursued by the Finnish physicist Gunnar Nordström, who in 1914 tried to use a 4th dimension of space to describe gravity. It didn't work though. The person to figure out how gravity works was Albert Einstein. Yes, that guy again. Einstein taught us that gravity does not need an additional dimension of space. 3 dimensions of space will do. It's just that you have to add 1 dimension of time and allow all these dimensions to be curved.
But then, if you don't need extra dimensions for gravity, maybe you can use them for something else. Theodore Kaluza certainly thought so. In 1921, Kaluza wrote a paper in which he tried to use a fourth dimension of space to describe the electromagnetic force in a very similar way to how Einstein described gravity. But Kaluza used an infinitely large additional dimension and did not really explain why we don't normally get lost in it. This problem was solved a few years later by Oscar Klein, who assumed that the fourth dimension of space has to be rolled up to a small radius, so you can't get lost in it. You just wouldn't notice if you stepped into it. It's just too small. This idea that electromagnetism is caused by a curled up fourth dimension of space is now called Kaluza-Klein theory. I have always found it amazing that this works. You take an additional dimension of space, roll it up, and out comes gravity together with electromagnetism. You can explain both forces entirely geometrically. It is probably because of this that Einstein in his later years became convinced that geometry is the key to a unified theory for the foundations of physics. But at least so far, that idea has not worked out. Does Kaluza-Klein theory make predictions? Yes, it does. All the electromagnetic fields which go into this fourth dimension have to be periodic, so they fit onto the curled up dimension. In the simplest case, the fields just don't change when you go into the extra dimension. And that reproduces the normal electromagnetism. But you can also have fields which oscillate once as you go around, then twice, and so on. These are called higher harmonics, like you have in music. So Kaluza-Klein theory makes a prediction, which is that all these higher harmonics should also exist. Why haven't we seen them? Because you need energy to make this extra dimension wiggle. And the more it wiggles, that is, the higher the harmonics, the more energy you need. Just how much energy? Well, that depends on the radius of the extra dimension. The smaller the radius, the smaller the wavelength, and the higher the frequency. So a smaller radius means you need higher energy to find out if the extra dimension is there. Just how small the radius is, the theory does not tell you, so we don't know what energy is necessary to probe it. But the short summary is that we have never seen one of these higher harmonics, so the radius must be very small. Oscar Klein himself, by the way, was really modest about his theory. He wrote in 1926, ob hinter diesen Andeutungen von Möglichkeiten etwas Wirkliches besteht, muss natürlich die Zukunft entscheiden. Whether these indications of possibilities are built on reality has, of course, to be decided by the future. But we don't actually use Kaluza-Klein theory instead of electromagnetism. And why is that? Is because Kaluza-Klein theory has some serious problems. The first problem is that while the geometry of the additional dimensions correctly gives you electric and magnetic fields, it does not give you charged particles like electrons. You still have to put those in. The second problem is that the radius of the extra dimension is not stable. If you perturb it, it can begin to increase, and that can have observable consequences which we have not seen. The third problem is that the theory is not quantized, and no one has figured out how to quantize geometry without running into problems. You can, however, quantize plain old electromagnetism without problems. We also know today, of course, that the electromagnetic force actually combines with the weak nuclear force to what is called the electroweak force. That, interestingly enough, turns out to not be a problem for Kaluza-Klein theory. Indeed, it was shown in the 1960s by Richard Kerner that one can do Kaluza-Klein theory not only for electromagnetism, but for any similar force, including the strong and weak nuclear force. You just need to add a few more dimensions. How many? For the weak nuclear force, you need 2 more, and for the strong nuclear force, another 4. So in total, we now have 1 dimension of time, 3 for gravity, 1 for electromagnetism, 2 for the weak nuclear force, and 4 for the strong nuclear force, which adds up to a total of 11. In 1981, Edward Witten noticed that 11 happened to be the same number of dimensions, which is the maximum for supergravity. What happened after this is what we'll talk about next week. This video was sponsored by the Great Courses Plus. I'm always looking for new brain food, and while YouTube...
Okay, so now let me just go to the other video that we've got here. Hold on a second. Oops.
In science fiction.
Hold on. So here's the second video.
In science fiction, hyperdrives allow spaceships to travel faster than light by going through higher dimensions. And physicists have studied the question whether such extra dimensions exist for real in quite some detail. So what have they found? Are extra dimensions possible? What do they have to do with black holes at the Large Hadron Collider and string theory? And if extra dimensions are possible, can we use them for space travel? That's what we will talk about today. This video continues the one of last week, in which I talked about the history of extra dimensions. As I explained in the previous video, if one adds 7 dimensions of space to our normal 3 dimensions, then one can describe all of the fundamental forces of nature geometrically. And that sounds like a really promising idea for a unified theory of physics. Indeed, in the early 1980s, the string theorist Edward Witten thought it was intriguing that 7 additional dimensions of space is also the maximum for supergravity. However, that numerical coincidence turned out to not lead anywhere. This geometric construction of fundamental forces, which is called Kaluza-Klein theory, suffers from several problems that no one has managed to solve. One problem is that the radii of these extra dimensions are unstable, so they could grow or shrink away, and that's not compatible with observation. Another problem is that some of the particles we know come in 2 different versions, a left-handed and a right-handed one. And these 2 versions do not behave the same way. This is called chirality. That particles behave this way is an observational fact, but it does not fit with the Kaluza-Klein idea. Witten actually worried about this in his 1981 paper. Enter string theory. In string theory, the fundamental entities are strings. That the strings are fundamental means they are not made of anything else. They just are. And everything else is made from these strings. Now you can ask, how many dimensions does a string need to wiggle in to correctly describe the physics we observe? The first answer that string theorists got was 26. That's 25 dimensions of space and 1 dimension of time. That's a lot. Turns out though, if you add supersymmetry, the number goes down to 10. So 9 dimensions of space and 1 dimension of time. String theory just does not work properly in fewer dimensions of space. This creates the same problem that people had with Kaluza-Klein theory a century ago. If these extra dimensions exist, where are they? And string theorists answered the question the same way. We can't see them because they are curled up to small radii. In string theory, one curls up those extra dimensions to complicated geometrical shapes called Calabi-Yau manifolds. But the details aren't all that important. The important thing is that because of this curling up, the strings have higher harmonics. This is the same thing which happens in Kaluza-Klein theory. And it means if a string gets enough energy, it can oscillate with certain frequencies that have to match to the radius of these extra dimensions. Therefore, it's not true that string theory does not make predictions, though I frequently hear people claim that. String theory makes the prediction that these higher harmonics should exist. The problem is that you need really high energies to create them. That's because we already know that these curled up extra dimensions have to be small. and small radii means high frequencies and therefore high energies. How high does the energy have to be to see these higher harmonics? Here's the thing. String theory does not tell you. We only know that these extra dimensions have to be so small we haven't yet seen them. So in principle, they could be just out of reach, and the next bigger particle collider could create these higher harmonics. And this is where the idea comes from that the Large Hadron Collider might create tiny black holes. To understand how extra dimensions help with creating black holes, you first have to know that Newton's 1/r² law is geometrical. The gravitational force of a point mass falls with 1/r², because the surface of the sphere grows with r², where r is the radius of the sphere. So if you increase the distance to the mass, the force lines thin out as the surface of the sphere grows. But here's the important point. Suppose you have additional dimensions of space. Say you don't have 3, but 3 plus n, where n is a positive integer. Then the surface of the sphere increases with r to the 2 plus n. Consequently, the gravitational force drops with 1/r to the 2 plus n as you move away from the mass. This means if space has more than 3 dimensions, the force drops much faster with distance to the source than normally. Of course, Newtonian gravity was superseded by Einstein's theory of general relativity, but this general geometric consideration about how gravity weakens with distance to the source remains valid. So in higher dimensions, the gravitational force drops faster with distance to the source. Keep in mind, though, that the extra dimensions we are concerned with are curled up, because otherwise we'd already have noticed them. This means into the direction of these extra dimensions, the force lines can only spread out up to a distance that is comparable to the radius of the extra dimension. After this, the only directions the force lines can continue to spread out into are the 3 large directions. This means that on distances much larger than the radius of the extra dimensions, this gives back the usual 1/r² law, which we observe. Now about those black holes. If gravity works as usual in 3 dimensions of space, we cannot create black holes. That's because gravity is just too weak. But consider you have these extra dimensions. Since the gravitational force falls much faster as you go away from the mass, it means that if you get closer to a mass, the force gets much stronger than it would in only 3 dimensions. That makes it much easier to create black holes. Indeed, if the extra dimensions are large enough, you could create black holes at the Large Hadron Collider, at least in theory. In practice, the Large Hadron Collider did not produce black holes, which means that if the extra dimensions exist, they're really small. How small? Depends on the number of extra dimensions, but roughly speaking, below a micrometer. If they existed, could we travel through them? The brief answer is no, and even if we could, it would be pointless. The reason is that why the gravitational force can spread into all of the extra dimensions, matter, like the stuff that we are made of, can't go there. It is bound to a 3-dimensional slice, which string theorists call a brane. That's B-R-A-N-E, not B-R-A-I-N, and it's a generalization of membrane. So basically, we are stuck on this 3-dimensional brane, which is our universe. But even if that was not the case, what do you want in these extra dimensions anyway? There isn't anything in there, and you can't travel any faster there than in our universe. People often think that extra dimensions provide a type of shortcut because of illustrations like this. The idea is that our universe is kind of like this sheet, which is bent, and then you can go into a direction perpendicular to it to arrive at a seemingly distant point faster. The thing is, though, you don't need extra dimensions for that. What we call the dimension in general relativity would be represented in this image by the dimension of the surface, which doesn't change. Indeed, these things are called wormholes, and you can have them in ordinary general relativity with the ordinary 3 dimensions of space. This embedding space here does not actually exist in general relativity. This is also why people get confused about the question what the universe expands into. It doesn't expand into anything, it just expands. What does this mean for space travel? Well, it means that traveling through higher dimensions by using hyperdrives is scientifically extremely implausible. Therefore, my ultimate ranking for the scientific plausibility of science fiction travel is third place, hyperdrives, because it's a nice idea, it just makes no sense scientifically. Second place, wormholes, because at least they exist mathematically, though no one has any idea how to create them. And the winner is warp drives, because not only does the mathematics work out, it's in principle possible to create them, at least as long as you stay below the speed of light limit. How to travel faster than light, I am afraid we still don't know. But maybe you are the one to figure it out. This video was sponsored by Audible.
Okay, so there you have my attempt to try and answer some of Stephen's questions about what in the world is going on here with these extra dimensions. I mean, again, remember the one of the rationales for the extra dimensions is that we have now realized we only have been dealing with 5% of the universe in what we call matter. And that means that 95% is someplace else, and the only place people can think it could be would be in these other dimensions. And the things that are vibrating there, things that are in the other dimensions, are vibrating at incredible frequencies and doing all kinds of amazing things to create all this, 95% of the energy and mass that we see, that we find in the universe all around us. So that was the real logic for having these extra dimensions, was to account for all of these things that we can't see, that we sense are there. And what the contribution that Ron did was to come up with these different, let me just go back here, have something to focus on. He was able to sense these other dimensions. Here's his picture. He's able to sense these other dimensions, but because they were compactified, they simply showed up. He could see that there was something behind whatever it was he was looking at, but it didn't mean that he actually saw these other dimensions per se. Bruce, did Ron ever talk to you about looking at these things and these compactified dimensions? I don't know. We talked about it a lot. Bruce, you're muted.
Yeah, not that I recall.
Yeah, it was something that I brought up. I kept pushing him on this to try and see if we could actually see something or measure something. And it was clear there was something there that he saw, but it wasn't. And the other thing to keep in mind, what Ron did, was this notion of information that coats the walls of the compartments of space all around us. This is the collective unconsciousness. This is where all the algorithms and the data resides that runs the universe. And that this, in fact, that one of the things that came up in the video I forgot to mention was they kept talking about the strong force and the weak force. And if you look at this thing right here, etheric electromagnetism, which is again on our website, I'm just going to go down here. This is the key thing that people like Nikola Tesla observed, is that the equations for fluid mechanics are identical to the equations of electromagnetism, but they have extra terms which reflect the fluid. And so if you just added in these terms and you had a fluid there, which we would call the ether, and then looked at carrying out what's called the perturbation analysis on Maxwell's equations, then the 0th order term, meaning that there is no ether, is we get Maxwell's equations, but the 1st and 2nd order terms give us the strong and weak force, and gravity shows up as the density of the ether varying, okay? Which is the same as saying that space-time curves. This is one of the things that's kind of crazy, is I could have empty space-time, but if it's curved, I have gravity. That's what Einstein showed. Okay, even though there's nothing there, I still have gravity. Go figure that one out. So anyway, this is.
But what about those pictures of the planets in space, where it looks like they're, you know, a marble on a blanket, creating that curve?
Yeah, the pictures are still there, that if there's mass, that you end up with warping of space-time, curving it, and that leads to gravity. That's all true also. I'm just pointing out that you know, if you're curving space-time, you know, you're not near, you're close to something, but you're not there. So you're not where the mass is that's actually causing it. Just the curved space-time has gravity, even though it's empty. So anyway, so with that.
Or it acts
All
like.
right, can I ask a question?
Yeah, go ahead, Steve.
In the video, if I caught what she was saying, the reason that these other dimensions are not visible is because they are too small. Is that in fact what she said?
Yes, the idea is that I tried to show them as rolled up or compactified. So I pointed my finger, here's my finger, and it's rolled up or wrapped up. So this is, say, the x-axis, and there's a compactified dimension, a compactified x-axis that's wrapped around this, okay? But its dimensions are so small that when I try and look at it and sense, you know, what's there, it has, again, vibrations in it, which are due to these strings she talked about. But the small size of it means that they're vibrating at very, very high frequencies, and the very high frequencies themselves, that's equivalent to needing very high energies. The higher the frequency, the higher the energy. And so the energies are so high, no one knows how high you have to go in energies to do this. And that's, she was talking about this, remember, with this Large Hadron Collider, which is the accelerator there outside of Geneva.
But it just strikes me that just off the top of my head, I can come up with 3 reasons why we might not be able to see other dimensions. One being that they're too small, a second being that they're too large, and a third being that we just don't have the visual acuity to be able to see that which might be right in front of our face. So, you know, I'm just curious as to what exploration might have gone into these other possibilities rather than just being too small.
What Tesla did in the 1890s was he actually gave some talks on measurements that he'd made with electromagnetic fields at frequencies greater than a megahertz, 1 million cycles per second, okay? And he saw something there. So since he saw something, that suggests it wasn't ridiculously small, okay? There was something there, but he didn't explain it this way, okay? He just said, I saw something. And that's the only thing I can point to. You can find all this on the web if you search out what Tesla did. there's probably, some little trick he did that escaped people, and we'll kick ourselves when we find out what it is that he really did. But that's where we're at today.
All right, thank
So,
Can
yes, Cheryl?
I just heard something interesting that's sort of related to the question Steve asked. Maybe that somebody was did some research on quantifying how much as humans we can see, and in terms of what's in the universe and how much can we hear. And the percentage was like 0.0000123. It was like such a small number that somebody was able to compute that was useful to me. I found that fascinating. I don't know if that makes any difference, Stephen, but I thought, and the same for audibly, that we maybe I don't know to say the word, if we were designed for this, but this is what our range is.
I mean, the only thing I could point to that's remotely like this is the following, that I mentioned, Ron looked at the chakras, okay, we have 7 of these major chakras, and that these are made up of this dark matter, or he called them mind forms, okay, each of the 7 chakras, but he never said how big they were, okay? And remember, they're really all made up of these subquarks, so they're already fractions of a proton or a neutron. They're teeny, and yet they could have, a whole pile of them clumped together and still be absolutely minuscule, okay? Now, collectively, these chakras make up what we call a soul in us. So people have said, let's wait for someone to die, and when they die, we'll see if we can detect a change in weight when the soul leaves. So people have done this, and they claim to see a fraction of an ounce change in weight, okay, when the soul disincarnates from the body, leaves. Okay. But on the other hand, the soul would be, I would say, going back to your comment, that's 99.999% of you. That's your soul.
Yep.
And so the rest of it is nothing. And that's how I get to where you started from.
Yep. And the other thing I was watching, I found something on YouTube that they were showing they could capture the audible sound of a black hole. And I listened to that for like an hour, 1 minute and 31 seconds today. And I thought, and it was such a cacophony. And of course it sounded very eerie, but it was also, it was perfectly timed for me with this notion of, I mean, I do believe we also have access to everything if we are open and capable of taking it in, because we are all part of the same thing. But I thought it was interesting that in some ways it helps us not go crazy, because we're not necessarily tuned for all this noise and all this vision and all this everything all at once. So we probably do better, in the confines that we operate as humans.
I viewed it that we have to evolve some more, and we got to higher levels of consciousness.
Yeah.
Then the music of the spheres really would be the music of the spheres, but there'd be music beyond that. Okay, which we'd have to evolve to, and so forth. So that was my takeaway on this.
Yeah,
Okay.
that's a good one.
Also, just another quick question regarding, pardon me, regarding the collider possibly creating tiny black holes. It just strikes me that if it's a black hole, it doesn't matter how tiny it is. Why wouldn't it be able to, by definition, being a black hole, be able to literally suck everything into it?
Well, it is, okay. every black hole, as you pointed out, it's black because all the energy that's thrown at it is it's absorbing whatever it can absorb. That's true. But the other thing that was observed was that the black holes radiate information. Okay, they even though they're black, just like we said, they also give off what's called a Stephen Hawking radiation, and that means that they're shrinking at the same time. Okay, both things are going on, and the rate at which the little itty bitty black hole can absorb things is very small. They actually just did some calculations for the black hole that's at the center of the Milky Way galaxy, which has a actual mass of 4 million solar masses. So the sun is one solar mass. So you could imagine this being 4 million suns in terms of mass. It's not that in terms of size, it's much smaller, but there it is. And they observed that even this thing, which is 4 million suns worth of gravity, worth of everything you could think of, is very inefficient at absorbing all of the energy that's being thrown at it. Very inefficient. And they're trying to figure out what in the world they don't understand. Why isn't it gobbling up more and more and growing incredibly rapidly huge, way beyond what it is now? So it's a good point. You've just hit the frontiers of knowledge.
But if it can emit information, that would mean that the information is not subject to the laws of gravity, and the information would have to be in a form that is I don't know, has different physical laws that would deal with it, that it
Right.
be able to exist and not be subject to gravity, for instance.
Right. That was what again, that was what Ron Cowan observed, was the information we're talking about, and the exchange of information is happening in these other dimensions that we don't sense. You're entirely correct. In fact, no one's actually seen this radiation we're talking about, this Hawking radiation. So it's got to be in these compactified dimensions. So I want to give Marjorie some time. I don't want to go too crazy here. So what do you want me to go to right now?
Well, it seems like it's kind of non sequitur now.
You wanted to go to your poem,
Go to the
or you want to go to this
no. Go to the video.
video? This.
Yeah.
Okay.
Well,
Here we go.
start with that.
This will get you up to speed. Here we go.
So I just want to. This is there are several versions of tori. Each one of these is a torus, Torus, which is thought to be actually the shape of an electron. Is that correct?
Yeah, that's what Ron observed.
So these are just, and then this is something that's been, discovered. You can create this shape as they're showing on the mathematical surface of the torus. So these are just, different ways of bending our minds around the question of space, which, modern thinking is pointing out we don't really even understand that. And that's where everything occurs, which is we don't know where. So this one, I just really love this. I could watch this all day. So in 2003, I started thinking about these shapes. I guess I was always drawn to Escher and MC Escher and the way he, played with 3D space. And so I was thinking about all of this. And at the time, well, I had moved to, this is another story we'll get to on the anniversary of September 11th. Our webmaster and I are going to do something about our intuitive experiences around September 11th. So this was in that time frame when I was up in Vermont, because my guidance had told me to get the hell out of downtown Manhattan. So I did, which was very out of character. But the guidance just kept saying, bring your computer and your books and your cats and get out of New York. And I did. And I had a library of esoteric books. So this is just sort of what I was thinking about at the time. I just had a very simple video in a folder, and I'm resurrecting this old Mac now and pulling these files off of it. So these are just now, these are new videos that are permutations on these concepts about multidimensional spaces. And even, I mean, this is all 3D, but it's just different ways of conceptualizing that. So I had written this poem. I started in 2001, but I dated it 2003. And this is one that I just pulled off the old, Bart had the old hard drive resurrected that had died from this computer. So I hadn't lost these files for several years. And I was really bereft over that. So it's been very, very healing to have them back. And little by little, I'm resurrecting them, looking at them, thinking about them for the first time in about 10 years. And putting them up on the website and sharing them with you. So thank you for bearing with me. I think I'm going to blow this up a little so I can read it. And I'm just looking for I have all these strange glasses now from this eye doctor. And I have some glasses for screens and some glasses for paper and some glasses for distance. I think I still need another pair. So this is a poem that I wrote. The experience was around 2001 when I left New York. And, but I committed it to paper apparently in 2003. And so the name is Taurus Rising, which is kind of a pun for me as an astrologer, but I was thinking about the shape of a Taurus. So I like the way he talks, and I feel this was a precursor to meeting Bart, who I met 20 years ago, but we didn't really talk until about 3 or 4 years ago. So anyway, this was sort of a pre-Bart. Another Scorpio. I like the way he talks, like a Japanese poet. Simple things about nature explode like black ink underwater, billowing in all directions. It's curious to think how laconic New Hampshire and double Scorpio can add up to such a delicacy, which most of the time makes me look down and bow out of a clever citified response. But sometimes I pick up on one of the unfurling reverberations. I want him to know I am listening, really listening, as he fells his trees in his dark and solitary forest. And I want to play in the waves he is making in my mind. At times he is amused or engaged by the counterpoint, taking the fugue on a new tack. Or sometimes he is startled at really being heard. Occasionally, he seems to deem my interloping as merely redundant, and I blush. And at other times, he is clearly uncomfortable with the harmonics of the unsaid being said, and so much lost in the translation. And I wish I had the right key. Secretly, I send 1,000 cancels too late and remind myself again that for a writer, this is a foreign language. And I vow to keep practicing my silence. Then our dark eyes meet, and it is like crows congregating 2 and 2 between the telephone lines, and words are murdered in their tracks. Until he stammers for something unleavened to say that won't turn 10 feet deep, that will not rise beyond a single flat plane. But he never does, and it always does. He builds houses from ground zero. A circle drawn in chalk becomes a spiraling staircase. Bentwood banister describing the arc, fine mahogany cabinets and parquet floors frame cubes of space. He adds alcoves and nooks where foxes chased rabbits and architects drew flat walls. He makes rooms to live in, boxes around air spaces to love in, to quarrel in, to make up in, to curl up with a good book and think and watch TV, to shower and eat in, to grow old in, to grow up in, to grow old in, perchance to be born and die in. He counts window panes and lights and know what that will do to my dark eyes. He brings me bright bits from his world, more precious than my footnotes falling flat from poison ivory halls. And I think not for nothing was Jesus a carpenter, an initiate of mysteries and miracles, geometry both sacred and plain, profane. He told me once about a lake turning itself inside out like an earthquaking donut of water, a phenomenon of thermal inversion like a thunderstorm, he said, which he sailed into habitually as a boy. It stank to high heaven, he said, as all the sludge rose up from the bottom and emergency oxygen was sucked into the vortexing vacuum at the center, replenishing the whole system. A torus rising, I ventured, and he smiled. He gave me a look at once playful and penetrating and challenging, and said, I guess you would say it was cleansing. Well, it was, we answered in unison. After a pause, he added, you wouldn't want to be out in the middle of that lake. It was a long time before I understood his warning about the undertow around his lonely hunter of a heart in search of itself. So again, my point is that this is what I was thinking about 20 years ago, all by myself in Vermont.
Thank you, Marjorie. That was really beautiful. Thank you for sharing with us.
Oh, thank you. So these are, to me, it's just become really fascinating to see how these thoughts spread among us. You know, what's the source of them? You know, who knows? I liked Escher. I liked, you know, these ideas. I did graphics, but I don't know where these ideas were coming from. They were coming from some source beyond myself. And I was having this kind of encounter with this carpenter and thinking of all these things that now are becoming so much more fleshed out and grounded and anchored by the context of what we're talking about. And it just seems like no accident.
Hmm. I think it's wonderful, this poetry that you write that's finally getting some visibility that's been locked away. It's just amazing, Marjorie. I mean, how crafted and flowing like this, your words are so great together. They're really wonderful. They're rich.
Well, thank you. Thank you. Yeah, it's been very, this one I've never shared, I don't think with anybody but Bart. So, thank you very much. I think it's part of my healing and resurrection. So,
Want to do anything else? Is that
I
it?
don't know, maybe just show the video one more time of
Okay.
all the different ways to slice.
That I have to go.
I
It's
don't
not-
think you
it's-
have to stop. I think you could just go to the other screen.
Go to the other.
Oh, and one thing, I just wanted to share this
Go ahead.
in the same folder from that same year. I found, well, it was just a still image of the Vitruvian Man. So that was part of what I was thinking about, and how to have that be part of the video and the whole thing about sacred geometry.
Do you want to do that?
No.
Okay. Where do we put it?
I don't
Oops.
know.
That took us out of screen share. Hold on. Oh,
There.
here it is. Okay.
So go back up to the top. Oops.
No, I have to go to here too. Here it is. And now we're going to go up
If you click there.
top.
Yeah.
So here's top. Okay.
So for me, the most. So this is true. I've read about it actually. I could add a footnote with a link to, I'm sure there's a good Wikipedia article. Lakes really do this. They really do form this shape. The circumstances have to be right with temperature and so on. I don't know if the chemistry is a part of it, but they turn themselves inside out. And the water forms a torus that is cycling and cycling like this. And it seems to be some kind of self-cleansing for the lake.
I think it would probably be going in the opposite direction in a lake.
You think it would be going? I think it goes from the bottom up
Exactly.
like this.
Yeah.
And that's why I made the pun Taurus rising. But we were like, two alien life forms. But somehow our minds were meeting in this very strange place. And, I think he especially just really didn't know what to do with it. But I know he thought about these things in, I would say, a less verbal way than I thought about it. But, that's kind of an interesting one. It's one within another. So that's a way of thinking about multiple dimensions and how they can be nested and so on. So I say that was a poem to Bart before I met him. And if I had ever shared any of this with that guy, I think he would have just like run out of the room. But I was writing to Bart. It anticipated him. And here we are now.
What is the source of all of these images?
I just found them online. There are people, and I suppose a lot of them are mathematicians.
Or artists.
And artists. But you can just look up, just Google Taurus, Torus, and animation. That's it. I had a very simple primitive animation in my folder at the time from like 2001 or so. But they're becoming more elaborate and color and everything. Mine was just black and white. And I had wanted to play with the animation. I had it in a form that I had all the stills to the animation, all the cells that go into making the image move like this. And I was thinking, well, that would be so much nicer if it was color, and there was a little more dimension to it. So that was what I was planning on doing, and somehow morphing that with the image of the Vitruvian man from Da Vinci, and that whole idea of squaring the circle and sacred geometry and the ratios of our bodies and everything else. And I was influenced by that paper that I wrote on Darcy Wentworth Thompson, that was around the same time. And thinking about his studies of, geometry and nature and the mathematics of all of it. So my point is that these things are also archetypal, and that we can reach them through our intuition. It's natural, it's not only academic and abstract and created by these esoteric scientists and mathematicians and physicists. It occurs in nature, and it's knowable directly.
So, oh.
That's all I would
No,
say.
I think that's wonderful. I'm gonna shut this down. Let's see, how do we do this? I'm just gonna go here. Does anybody else have anything they want to say? We will wrap it up otherwise.
Yeah, I like that collection of Tauruses. I mean, it's fascinating. It's just, it is endless. It is mesmerizing every time I see them too. And I don't know if I don't know, I've seen phenomenons in streams and ponds where you get the water turning into little funnels, but I don't think it's the pond flipping over, but that's cool. Or the lake flipping over. But I can believe that could happen. That doesn't take that. I could absolutely believe that could happen. It's pretty cool.
Well, we'll send them out with the
Yeah, nice collection. Great collection of stuff. And your poetry is great. And I hope maybe you publish some of this someday to get it more exposed. It's pretty good, Marjorie.
Oh, thank you.
It's pretty amazing. All through your life you were doing this. So, you've been doing this for, you didn't start this yesterday.
So it was just always kind of like a secret self thing, it was
Yeah.
a back burner thing that there really wasn't. I had actually, it started out in Westport. There was a spiritual bookstore, you might know it, Stephen, Pymander. Did you ever hear of Pymander? And at one point I did readings there. And it started in Westport, and then it moved to Norwalk with a new owner who took it over. And she had me host an art show there with my collages. And the opening was a poetry reading. So they were all paired, and I sold greeting cards
Wow.
there that I printed out of and prints. And so that was a nice experience. And that seemed to be a good setting. And I did a talk and a reading, and it was in a blizzard in February. It was for my birthday.
Wow.
And people came out of the woodwork. It was really amazing. It was really nice. So that was kind of one of the most rewarding public things, but I didn't really have it on a website or anything like that at the time. So that's what I'm doing now.
That's good. Huh? That's great.
And so there was a series of cards with prints on the outside and the poems. I have this like vellum kind of paper that I insert into the card, and then tied it with a ribbon, so it made
Right.
this kind of nice presentation.
Yeah, that sounds really nice.
So that was a back burner project at one point.
You were able to present your own work and sell these. It was your own thing.
Yes, yeah,
And you just do those things sporadically?
yes, exactly.
Well, I'll tell you something that couldn't be more simple that really helped me personally in a very profound way. Just simple sort of maxim of like, well, what do writers do? Or this goes for whatever enterprise one is involved in. Writers write. So I at some point in my life I decided that I was a writer, but I wasn't writing very much. So I would say that to myself again and again, and it was very, very motivating to the degree that I write every day, because that's what writers do,
Right.
So if you create a self identity as whatever it might be, just say, well, so-and-so's do such and such, and motivate yourself. It worked for me, it might work for you.
Well, thank you. That's good. That's like something out of the artist's way,
Mhm.
which I'm kind of doing by myself now, and thinking that. And I used to say, well, I think humans make art. Birds fly and fish swim, and to me, art is really a human activity.
Except for some elephants and chimpanzees.
Right. Right.
Yeah, and a couple of pigs, and then I saw, and I saw actually a program. I think it was Alistair Cook, maybe, showing how beautiful birds make their nests,
Yeah.
and that would be hard for me not to call it art, because they would go and find beautiful little threads and colors and things that they had to have, something going on there.
Right. Right.
Well,
Right.
that goes to a distinction between art and craft. Art requires craft, but you have to infuse emotion into the project for it to migrate from craft to art.
Hmm. And the corollary, exactly. There's a bird nest here at the rookery of wood storks, and in the nest photo they had a live cam, and these wood storks, these are very large nests, longer than my arms, the twigs that they're made out of, and they had all kinds of trash in their nests. And I thought, wow, I guess there's a distinction. Some birds are kind of trashy, and some birds have a fine art of making a beautiful nest. I'm like, well, look at that.
Art isn't too different from humans.
Exactly. So, Stephen, can we ask you, have you published anything? And are you continuing to write? And can you share anything about what you do with your writing, or is it just personal?
Right now, I'm working on developing a musical that I've written the book lyrics and music for, all of the above.
Yeah.
And, so I'm in the process of trying to develop it and get it produced. It's a humongous project that typically is done as a collaborative effort, which makes it an awful lot faster and easier, but I'm a do-it-yourself kind of guy, and so I'm doing it myself. I'm getting it to the point where, okay, I can't, I can't, unless it were, a one-man show, I couldn't continue to do it myself. So I'm at the junction now where I need to get it out into the world, and so that's what I'm working on.
Oh, neat. Now, do you have a background in writing music, or a musical background? Or is this all something new, part of this adventure of writing this musical?
Well, I have a music background in that I've been playing one instrument or another since I was a little kid,
Okay.
but I don't have the academic background for what I'm doing. It's a part of the process for me is learning how to do whatever it is I need to do. I've been doing that both vocationally and otherwise my whole life. So I find myself in a situation where I need to get something done. So I learn how to do it, and then I do it. And so just regarding this as a project, it's not just the writing or composing that's involved. I had to learn how to do studio engineering to be able to, record and edit tracks. It's like I have to learn how to create a website, and it goes on and on. There's just no end of different things that most people get involved and get other people to do these various aspects. But as I need to get any given task done, I go out and I learn how to do it, and then I do it, and then I move on to continue with whatever other parts of it. And so it becomes, it's a very interesting thing to me. I've always had a very great breadth of interest, such that for me, it doesn't matter what the subject is, it's potentially interesting, so I just go and I happily learn how to do whatever it is.
Oh, that sounds so interesting. Well, I hope you'll keep us updated as this progresses, and when we hopefully will get a chance to watch this performance.
I hope I get that far, and I'll be happy to provide tickets if that day ever comes.
Well, it will come. It sounds like it's been part of your life's journey, so it's exciting.
It strikes me as it's like the what's the school that Emil went to?
Montessori.
It's like the Montessori approach, that anything that interests the child becomes, the vehicle for their learning. If you want to make a cake, you have to learn what half a cup is as opposed to a cup, and so you learn fractions in cooking, and you're learning, whatever it takes. I was very moved when I learned that you joined a choir, and then from there took singing lessons in order to further your musical.
There was a flow chart to that in this kind of very silly sort of a way. After church one Sunday, I went to Ed, who was the minister of music at the Unitarian Church, and
the big meditator, by the way.
The what?
And a big meditator, by the way, I said.
Well, you know, as if Ed would have a magic bullet. I mean, it was, I asked this question both in the most naive and sort of idiotic fashion. I knew that I had to be able to, in order to have this project progress, I would need to be able to sing what I was writing from time to time. There would certainly be these situations where that was required. And I really didn't know how to sing. And so I went to Ed and I said, do you have any kind of course, of action you'd recommend for me to be able to progress there? And he said, what are you doing tomorrow night at 7 o'clock? And I said, nothing. And he said, well, there's a choir practice, come and sing with the choir. I ended up joining the choir and went from there, and I learned how to sing. So.
Wow. Oh, that's great.
Okay, we're going to wrap it up, and we'll catch everybody next week, and have a wonderful weekend.
You guys do. Bye-bye.
Good night, everyone. Nice
Keep
to see you.
exploring.
Yeah, keep exploring. Okay.
Hey.
Good night.
Good night.
Bye.